Welcome to LNP Renewable System Editor. Today we are going to discuss some of the basics of electric vehicle part 20. So this session we had classified into 25 parts. If you have missed out any parts, no issue. Please subscribe to our channel and press the bell icon. In our channel we had created a playlist. By getting into that playlist, you can able to watch all the 25 parts that we had discussed. So in our discussions we might be using so many abbreviations. So if you have any doubt with the abbreviations of the short forms, then you can refer this one. What are the things that we are going to discuss today in our session today? We might be discussing what is off-board charging system and where it is used in the electric vehicles, and what is on-board system and where it is used in the electric vehicle, how AC and DC charging systems of an electric vehicle looks like, and what are the different power charging ratings of an electric vehicle, how battery swapping is done, and what are the challenges in a battery swapping. So when we get into the off-board charging system, it is specifically designed to transfer high kilowatt of power and requires a more sophisticated battery management system for plug-in type hybrid electric vehicles. And this onboard, where we are using this onboard charging system, this onboard charging is used in the places where low kilowatt of power transfer we need to do. Okay, but it adds a significant weight to the plug-in type hybrid electric vehicle. See here, this is an example. See here, we have a BMS and we have a battery. Through the DC charging, we can directly charge our batteries. So we are using the DC fast chargings. Through solars also we can charge our battery at a fast rate. If you have an onboard charger, through the AC charging methods also we can charge. So we can classify our charging methodology into two, AC as well as a DC. For the kilowatt range of 2 to 22 kilowatt, we can go for AC. If it is more than 200 kilowatt, then we can go for DC. From 2 to 200 kilowatt, we can go for DC charging. Okay. And in the AC, as per Indian standards, we have 3 different pins available. 3 pin, type 1 and type 2 pins we have. Whereas in case of DC, we have a CADIMO and combo 2 type 2 pins. So typically, when we consider a AC charging system, consider this is a AC charging system power flow. We have a battery pack, we have a BMS inside it. See here, this is electric vehicle storage. Okay, and we have a grid. So from the grid we are getting AC power through the pilot wire. This electric vehicle is communicating with our AC charging system. Okay, through the pilot wire. And if the switch is closed, so the entire charge will go to the power bank through this AC to DC converters. Okay, and in our AC charging system we have 2 levels. One is level 1 and level 2. For the rated current of 12 amps to 16 amps, we will be using the level 1 type, where it is a single phase. Okay, whereas in case of level 2, say for example for the commercial locations like malls or offices, there if the current rating is more than 15 amps to 80 amps, then we can go for this level 2. And in case of DC charging, see here we have a grid, we have a AC, and we have a EVAC plus AC to DC converter with inbuilt. We have a pilot wires also. Okay, since we have AC to DC converter connected directly, by bypassing this converters, we can directly charge our batteries. So this is our electric vehicle. We have a DC system charge flow diagram. So from the grid we are getting AC supply, and through the EVAC and the AC to DC converters we are trying to charge our batteries directly. Okay, so we can have 2 charging methodologies in the DC charging system. Either we can use external charging to supply our high voltage DC at 400 amps directly to the vehicle battery, or we can bypass the onboard charger on the electric vehicle. So high power is directly supplied to the vehicle. So the overall time required to charge will get reduced if you use this method. And we have a EVAC power ratings for based on our electric vehicle segments. Say for example, if you're going for two-wheelers and three-wheelers, or light commercial vehicles, then we can go for this normal power charging method where the power level will be less than or equal to 7 kilowatt, or in certain range we have 7 kilowatt to 22 kilowatt range. So in such occasions, either we can use both AC and DC type. But when you're going for a car or a light commercial vehicles or a medium commercial vehicles which is weighing around 1 to 6 tons capacity, in such places your power level requirement can be from 22 kilowatt to 50 kilowatt, or from 50 kilowatt to 200 kilowatts also. So in such occasions, the better option is the DC current type. So battery saving, even in our New Delhi's, we are using the battery autos, where see here, this is a battery. So if we want to charge it, we can either put and swipe the card and charge it up to 80% if you have a time, or otherwise what we can do, we can give the discharged battery there and we can take the charged battery outside, so that the exchange is happening, so we can make a quick interchange in the station itself. So what are the advantages and challenges of battery swapping? Because the biggest advantage is that we can make the EV recharging in a minute. Okay, but only thing is that we need to make the standardization of the electric vehicle, because now so many brands are available in the market. Then we need to make a standardization, because some persons will create a electric vehicle with some sort of battery specification. Okay, same batteries we cannot use for the other vehicle. So such sort of disadvantages or barriers are there. So we need to make a standardization. Whomsoever who creates an electric vehicle for an auto, then they should follow these sort of standards. Your battery size should be like this. You need to follow this sort of electrodes. You need to have this sort of charging capacities. You need to have this sort of BMS or protections inside those batteries. Like this, such sort of creations they need to make. Because if you make that standard, then only we can overcome this barrier of battery swappings. Okay, and cost wise we should be efficient, because if one person is even though they are following the standardization, but if one person is keeping high cost for a particular battery and a very low cost for other battery, people with a cost mindset, they will try to choose the one which is having a less cost or a medium cost with a good efficiency. And most importantly is that we need to create an infrastructure where greater number of batteries we can charge at the same time with the same power. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We can provide the contact details here. So we, LNP Renewable System Integrator, we are providing PLC programming training along with the certification, ISO 9000 2018 certification. So you can learn Siemens, Hallenberg, Delta PLCs programming with us. And if you have a plan to work in the GCC countries, we are also providing building management system, building automation control system courses along with the certifications. And if you're really interested to learn the electric vehicle basics along with the certification, then you can contact us. We are providing the contact details here. We are providing training along with the certification. And if you have a plan to establish solar on-grid, off-grid and hybrid applications to your homes or your factories or your locations, we are providing design, installation, testing, commission, consultancy and training supports also. And if you have a plan to establish the DC lighting system for the places where the EV power is not available, then you can contact us. We are providing support. And if you had a plan to provide a fencing to your agricultural farms, then you can contact us. We are providing solar fencing as a kit. Thank you so much.